So in this class, we shall discuss few previous year's questions on chemical bonding. Now the first question, which among the following will have the highest melting point? ঠিক আছে, কোনটার মেল্টিং পয়েন্ট সব থেকে হাই হবে? দেখো এখানে দেওয়া আছে লিথিয়াম ক্লোরাইড, lithium bromide, lithium fluoride, lithium iodide. Now, first of all, we need to understand that lithium plus, its size is very small. So naturally, uh, charge by size, that is the ionic potential is very high. Since the size is small, its polarizing power is very high. Polarizing power is high. Now, if the corresponding anion is large in size, that means as we move from fluoride to chloride to bromide to iodide, what will happen? The size of the anion will increase. So naturally, the covalent character will increase from lithium fluoride to lithium chloride to lithium bromide to lithium iodide. So lithium iodide, this will be most covalent. This will be most covalent, and this will be least covalent or more ionic, but most ionic. So if it is most ionic, then its melting point will be the highest. It should have the highest melting point, So naturally, the answer should be lithium fluoride. So lithium fluoride should have the highest melting point. So this is the answer. So let us consider the next question. Now, in this case, the degree of hydration, which will have the maximum degree of hydration? The degree of hydration is maximum for fluoride, K plus, Na plus, and Cl minus. Now, normally, uh, if we look at this hydration, see Na plus, size of Na plus, radius, this is smaller than radius of K plus. Okay, and obviously the size of fluoride ion, this is larger than Cl minus. Now it has been found that the radius of F minus, okay, this is close to that of K plus, but in the case of F minus, so we know that smaller the size, the charge density, whether it is positive or negative charge, the charge density will be higher. That if the charge density is higher, then the extent of hydration by water molecules, it will be higher. Greater the positive charge density or negative charge density, greater the positive charge density or the negative charge density, greater will be the extent of hydration, isn't it? So one should expect that these two having similar size, their hydration enthalpy should be close. But for fluoride, the hydration enthalpy is much more negative, because in addition to this ion dipole interaction, in addition to this, see there is ion এটা হচ্ছে dipole. So in addition to this ion dipole interaction, there will be some amount of hydrogen bonding due to the smaller size of fluoride. So it is due to the smaller size of fluoride, there will be some amount of hydrogen bonding, and that's why the extent of hydration for fluoride will be the highest. One should expect that the extent of hydration for fluoride will be the highest. This is due to, first of all, there will be ion dipole interaction as well as hydrogen bonding. Now let us come to the third example. The values of Madelung constant of Al2O3 দেখো the values of Madelung constant of Al2O3. Value Madelung constant usually we denote it by capital A. Of Al2O3, calcium oxide, sodium fluoride and KCl, they are equal. Then the lattice energy will be of the order. If these are considered to be equal, we know that as per Bond-Land equation, this U0 equals minus A Z plus Z minus E square by 4 pi epsilon 0 R into 1 minus 1 by N in kilojoule mole inverse. Now, there are the two major factors, deciding factors. একটা হচ্ছে দেখো, এইটা হচ্ছে Z plus Z minus. This is one of the deciding factors. Another deciding factor, you know that this varies with Z plus Z minus. And U0 also varies with R. So R is actually the radius of cation plus radius of anion. U0 varies inversely with R, or radius of cation plus radius of anion. Now, see, for if you look at the Z values for Al2O3, you know aluminium is trivalent and this is oxygen is oxidation state 2. So Z plus equals 3 here and Z minus equals 2, isn't it? So, but according to Bond-Land equation, see for Al2O3, Z plus Z minus will be the highest. Then comes calcium oxide. For calcium oxide, you see, bivalent calcium. So Z plus equals 2, Z minus equals 2. And for sodium fluoride as well as KCl, Z plus equals 1, Z minus equals 1. So the one which should have the highest value of lattice energy should be this one, Al2O3, because U0 will be 6 times this, 6 গুণ বেশি হচ্ছে. So we have to consider among these two, one should be correct. So the second will be obviously calcium oxide, because 2 into 2, so this portion will be 4 times, isn't it? So up to this, in both cases it is same. Then comes sodium fluoride and KCl. Among these two we have to choose which should have the highest lattice energy. Now if you look at sodium fluoride and KCl, obviously for sodium fluoride, this factor, radius of Na plus and radius of F minus, summation of these two, আমি বলতে চাইছি radius of Na plus plus radius of F minus, obviously this is lesser than radius of K plus plus radius of Cl minus. So U0, since it varies inversely with the summation, so since this is lower, so lattice energy of NaF should be, the magnitude should be higher compared to KCl, isn't it? So the correct option will be B. So B will be the correct option. Let us go to the fourth problem. Which of the following fluorides will have non-zero dipole moment? So by using VCPR theory, we can find out the structure 8 plus 4, 12. And we know that there will be two lone pairs. দুটো lone pair হবে এখানে. এবার দুটো lone pair যদি হয়, the two lone pairs will occupy positions trans with respect to each other. So it is non-polar. Non-polar আমরা দেখতে পাচ্ছি. CF4 is tetrahedral as per VSEPR theory, and you know that a tetrahedral molecule যদি হয়, tetrahedral molecule হলে কি হবে? tetrahedral molecule যেখানে সবকটা substituents are similar, all the substituents are similar, so it is obviously non-polar. This is also non-polar. Now if you look at SF4 6 plus 4 10 TBP structure, now in TBP structure you know that there will be a lone pair, and the lone pair will occupy equatorial side. So although these two bond moments they will cancel each other, but these two bond moments, they will not cancel each other, and hence there will be an effective dipole moment. So this will not have zero dipole moment. And for PF5, we know that it will obviously have zero dipole moment, isn't it? TBP structure. So our answer is C. Going to the next problem. The atomicity and total number of bonds, in elemental phosphorus are respectively. So we should know the structure of elemental phosphorus. See, if you look at phosphorus, see the geometry, the structure is like this. দেখো চারটে phosphorus, they are linked to each other. The four phosphorus atoms, they are at the corners of a tetrahedron, and they are linked like this. ঠিক আছে, তার মানে কটা phosphorus tetraatomic, and how many bonds are there? 6 bonds. So atomicity is 4 and the total number of bonds is 6. So the answer to this question will obviously be B. And one more thing, arsenic. If you look at arsenic, the structure of arsenic is also like this. So this is white phosphorus. And if you look at red phosphorus, it has polymeric structure. How the polymer extends? See, the four phosphorus atoms are linked like this, but there will be 4 bonds, and 4 এখানে এই 5 6th বন্ডটা হচ্ছে না, 5টা বন্ড হচ্ছে দেখো এখানে। And once again, this is how, see, the polymer will extend. এইভাবে extend করছে পলিমারটা। This is in the case of red phosphorus. So going to next question. The average CC bond order in graphite. Look, if you look at graphite, the structure of graphite, it has layered structure. Probably you know this. It has layered structure where each of the layers, this is a particular layer, these layers are made up of hexagonal units of carbon. This is how the layers extend. Okay, they are made up of hexagonal units of carbon. And if you look at each carbon atom, now this 2s 2p 2s2 2p2, this is the ground state. এটা কি হবে, এখানে excited হবে, এই excited state, this is the excited state. Now if you look at each carbon, the geometry around each carbon is planar trigonal. দেখো প্রত্যেকটা কার্বনের চারিদিকে জিওমেট্রিটা আমরা কিরকম দেখতে পাচ্ছি, প্ল্যানার ট্রাইগোনাল। দেখো এই একটা দুটো তিনটে এরকম প্ল্যানার ট্রাইগোনাল. So one should expect that the state of hybridization should be sp2. So these sp2 hybrid orbitals, they will be involved in the formation of sigma bonds with each carbon, and there will be a vacant p-pi orbital, a p-pi orbital which will contain an unpaired electron, isn't it? A p-pi orbital containing an unpaired electron. And each of these orbitals Each of these orbitals, electrons, they will contribute to the formation of pi bond. তাহলে আমরা দেখতে পাচ্ছি এইখানে একটা ইলেকট্রন তিনটে পাই বন্ড করছে, কিন্তু ঠিক একইভাবে এইখানে আরেকটা ইলেকট্রন তিনটে পাই বন্ড করছে। তার মানে effectively it is forming 1/3 pi bond. So that's why 1 sigma plus 1/3 pi. So this is basically 4/3 bond order. So bond order is expected to be 4/3. So it's like this. Going to next question. Now if you look at এখানে বলছে the compounds having SS single bond is. আচ্ছা, before moving into this we shall discuss, I'll show you the structures of different oxo acids of sulfur. যেমন ধরো, you know the structure of H2SO4. This is H2SO4. Next, H2SO3. Sulfurous acid. Sulfuric acid হলো, this is sulfurous acid. Next হচ্ছে H2S2O3. This is thiosulfuric acid. Thiosulfuric acid. So thiosulfuric acid, if we look at thiosulfuric acid, the structure is somewhat similar to sulfuric acid, except that one of the oxygens, it is replaced by sulfur. One of the oxygens replaced by sulfur, and it has been found that there is a tautomeric equilibrium, যেখানে এইটা দেখা যাচ্ছে যে এইখান থেকে এই প্রোটনটা নিচ্ছে, এইটা চলে আসছে। So it can also exist in this form also. Both the forms have been found to be stable. দুটোই কিন্তু stabilize করে, ঠিক আছে? So both these structures are known to exist for thiosulfuric acid. দুটোই possible, ঠিক আছে? Both the structures, they are stable. Now next চলে আসছি H2S2O4. This is known as dithionous. H2S2O4, this is dithionous acid. Dithionous acid. So dithionous acid, there is a sulfur bond like this. আর কি আছে, এই double bonded O, OH, double bonded O, OH, and lone pairs. This is dithionous acid. দেখো H2S2O4. This is dithionous acid. Then if you look at dithionic acid, dithionic acid, তো dithionic অ্যাসিডটা এই dithiionous অ্যাসিডের মতোই হচ্ছে একবারে, except for the fact that instead of the lone pairs there will be another double bonded oxygen. এই লোন পেয়ারের বদলে একটা ডাবল বন্ডেড অক্সিজেন। তার মানে আমরা দেখতে পাচ্ছি এই যে সালফারটা, this sulfur is tetravalent, but these two sulfurs, they are hexavalent. দেখো 6টা বন্ড আছে, number of bond indicates a valence state. In this case there are 4 bonds, so tetravalent. In this case there are 6 bonds around sulfur, so it is hexavalent. So this is a dithionic acid. Okay, next if you look at ধরো H2SO5, you know that this is Carrot's acid or peroxo monosulfuric acid. Okay, Carrot's acid or peroxo monosulfuric acid. এটা একবারে সালফিউরিক অ্যাসিডের মতোই, except one of the OH is replaced by OOH, peroxo group, peroxo monosulfuric acid. Okay, next H2 uh, S2O7. This is known as oleum or fuming sulfuric acid. So fuming sulfuric acid বা oleum it's like this SOS bond থাকে, and around each sulfur দেখো একটা OH থাকছে আর দুটো করে ডাবল বন্ড। So this is oleum. Then peroxo disulfuric acid, peroxo disulfuric acid, peroxo disulfuric acid often H2S2O8, peroxo disulfuric acid, and this is one of the strongest oxidizing agent. অনেক সময় দেখবে পার ডাইসালফিউরিক অ্যাসিড বলে। So পার ডাইসালফিউরিক অ্যাসিড means it's like this, S দুটো সালফারের সঙ্গে দুটো অক্সিজেন এইভাবে লিঙ্কড আছে, and around each sulfur দেখো the geometry is tetrahedral, একটা করে OH আছে আর দুটো করে ডাবল বন্ডেড অক্সিজেন আছে। So this is the, তার মানে পারক্সো এটাকে বলে ডাইসালফিউরিক অ্যাসিড, ঠিক আছে। And there is another group of acid known as polythionic acid or polythionic acid এর একটা নাম হচ্ছে সালফেন disulfonic acids. Sulfane disulfonic acid. Now what are sulfanes? Sulfanes গুলো হচ্ছে এইরকম, এইগুলোকে বলে সালফেন। এটা তো H2S, ক্যাটিনেশন সালফারে হয় বলে এইরকম H2SN, এইটাকে বলা হচ্ছে H2SN টাকে বলা হয় সালফেন। নাও এই সালফেন গ্রুপ আছে along with sulfonic acid SO3H। সালফোনিক অ্যাসিডটা কি? SO3H, দেখো SO3H ডাইসালফোনিক অ্যাসিড হচ্ছে, দেখো দুখানা সালফোনিক অ্যাসিড, সালফেন হচ্ছে আর দুখানা সালফোনিক অ্যাসিড হচ্ছে। So this is the sulfane moiety and there are two SO3H groups. So sulfane disulfonic acid or polythionic acids, ঠিক আছে। So it starts with minimum number of sulfur atom, x equal to 1 होता है minimum. So it starts with S3, isn't it? H2S3O কত হচ্ছে 1 2 3 4 5 6, it starts with H2S3O6. This is trithionic acid. So it does not fall under the category of, I mean, this dithionic acid. If you look at the last page, if you look at this dithionic acid, দেখো dithionic এখানেও SO3H group আছে, দেখো SO3H group, but it does not fall under the category of polythionic acid because sulfane is not present here. So dithionic acid যেটাকে আমরা বলছি H2S2O6, it does not fall under the category of polythionic acids. Okay. So let us come to this question. The compound having SS single bond. See, although the compound having SS single bond, আমরা এক্সপেক্ট করবো এইটা, this one, দেখো H2S2O4, H2S2O3 তে SS single bond হচ্ছে বটে, কিন্তু দুটো স্ট্রাকচারের মধ্যে ঘোরাফেরা করছে, both the structures are stable. So naturally, there is an equilibrium between both the structure. So it is not a true single bond. Okay. So our answer will be this one. This is our answer. Let us come to the next question. For the oxidation of sodium thiosulfate to sodium tetrathionate, the equivalent weight of sodium thiosulfate will be. So this is very simple. If we write down, if we write down the half equation, দেখো S2O3 2 minus থেকে S4O6 2 minus, তাই তো দেখো S2O3 2 minus থেকে S4O6 2 minus, so এই 2 minus কি হচ্ছে 2 electrons, so effectively it is S2O3 minus electron equals half S4O6 2 minus. Since we are considering the equivalent weight, we are finding out the equivalent weight, we have to consider per S2O3, isn't it? Per S2O3, it's a 1 electron transfer. So naturally, it will be molecular weight by 1. Per S2O3 2 minus, it's a 1 electron transfer. So this will be the answer. Going to next question. The number of PO bonds present in eta H2P4O7. দেখো compounds which are formed by POP linkages, দেখো যেমন ধরো এইটা, অর্থাৎ this is an oxo acid of phosphorus যেখানে POP linkage আছে, মানে this is H4, তাই তো H4 P কতগুলো আছে P2, ও কতগুলো আছে 1 2 3 4 5 1 2 3 4 5 6 7 O7. Then if you look at তিনটে oxygen যদি থাকে phosphorus, if there are 3 phosphorus like this, see one has to understand that the that this the oxidation state, the valence state of phosphorus is 5 here. Okay, that's why there will be 5 bonds. So if the valence state is 5, it should be like this. It should be like this. দেখো 5 করতে গেলে it has to be like this. তাই না? It has to be like this. তাহলে this is H কত হচ্ছে বলো, H 1 2 3 4 5, H5 P 1 2 3 P3 আর O 1 2 3 4 5 6 7 8 9, like this. Okay, so this is H2P4, এটা হচ্ছে, so if there are 4 phosphorus 1 2 3 4 PO PO, so this is এটা তো H2P4O7 হচ্ছে না, so this compound is এখানে অনেকগুলো ফসফরাস চলে আসছে, সো P4O7, P4O7. Just a minute, let me check the structure. Just a minute. Two. Just a minute, let me check the structure, please. একটু ওয়েট কর। Oh, the question is wrongly given here. Question না ভুল দেয়া আছে। So actually it is H2P2O7. Very sorry. The question is wrongly given here. The question H2P2O7. Okay, that's why it's not coming. So if it is H2P2O7, then it's fine. Then there will be two PO double bonds. দেখো যদি চারটে ফসফরাস হতো, it should be like this: H 1 2 3 4 5 6 H6 P4 ও হচ্ছে 1 2 3 4 5 6 7 8 9 10 11 12 13 ও 13, তাই তো? দেখো 3 4 আর 2 6 7 9 10 13, it should be like this. Otherwise it is H2P2O7. If it is H2P2O7, then the number of P double bond O, it's quite okay. Then it should be 2. আর এখানে আনসারটা এই কোয়েশ্চেনটা there was a typographic error from my part, so that's why problem হলো. So this is the answer. Going to next question. The most probable oxidation states of chromium and molybdenum are. দেখো ক্রোমিয়ামের ক্ষেত্রে তুমি যদি ভাবো, if you look at chromium, আমরা তো জানি ক্রোমিয়াম, তার নিচে মলিবডেনাম, তার নিচে টাংস্টেন। এখন ক্রোমিয়ামে তুমি যদি দেখো 24 আর্গন, 3d5, we know this, 4s1, এবং ক্রোমিয়ামের অক্সিডেশন স্টেট কি হয়? স্টেবল অক্সিডেশন স্টেট গুলো +2 +3 এগুলো তো হয়। তার মানে কি বলেছে? ফর বোথ ক্রোমিয়াম এন্ড মলিবডেনাম, তার মানে +2 +3 তোমাকে তো ইনক্লুড করতেই হবে, ঠিক আছে? আর ইউজুয়ালি অ্যাজ ইউ মুভ ডাউন দ্য গ্রুপ, what happens, the highest oxidation state is stabilized. তাই এখানে highest oxidation state মানে কি? +6, তার মানে +2 +3 and +6, this is the possibility for both. বুঝতে পেরেছো? As you move down the group, the higher oxidation state, the highest oxidation state will be stabilized, that is +6. So we know that for chromium, আমরা তো জানি ক্রোমিয়ামে CrO4 2- যখন করছি +6 হয়। ঠিক একইভাবে ক্রোমেট যেমন molybdate is like this, তুমি অ্যামোনিয়াম molybdate ইউজ করো, so molybdate is like this, so +6 oxidation state is stable for molybdenum. So the answer is এটা. So going to next page. In the structure of the molecule, this molecule, in the structure of B4, O5 OH whole 4 2 minus. Which is the correct statement? So first of all, we need to know the structure. This is a very special molecule, and unless you know the structure, you won't be able to explain. So you'll find that there are 4 boron atoms. There are 4 boron atoms, and these boron atoms, they are linked by a oxygen atom, BOB linkages. দেখো এরকম BOB লিঙ্কেজ আছে। এবারে যে কোনো দুটো বোরন, মেবি দিস টু, OH, আর বাকি বোরন দুটোর মধ্যে দেখবে there is a boron boron bond and also OH group. So there is a negative charge at each of the boron centers. কারণ বোরনে দেখো 4টি ইলেকট্রন চলে আসছে। So this is the geometry around each of the boron. তার মানে আমরা দেখতে পাচ্ছি যে around each of these boron, see these two boron, the geometry is planar trigonal, and around the other two boron centers, if you look at the other two boron centers, see the geometry is tetrahedral, like this. Around the other two boron centers, the geometry is tetrahedral. Okay. So that was the correct answer. If you look at the correct answer, you'll find that 2 boron atoms are tetrahedral while 2 boron atoms are trigonal planar. This will be the correct option. দেখো এখানে কি বলেছে, all boron atoms are planar, trigonal planar, which is incorrect. One boron atom is tetrahedral while other 3 trigonal planar, incorrect. 3 boron atoms are tetrahedral while 1 is trigonal planar, incorrect. 2 boron atoms are tetrahedral while 2 boron atoms are trigonal planar. So this is the correct answer. So this is the correct answer. So considering this question, B2H6, the number of 3-centered 2-electron bond in B2H6. দেখো এই B2H6 এ তোমরা সবাই জানো যে in B2H6 there are 2 BHB bridge bonds, if you remember. এই BHB bridge bonds এখানে দুখানা থাকে এই bridge bonds. So there are 2 BHB bridge bonds. তার মানে these two are 3-centered 2-electron bonds. So the answer will be 2. This is very simple. Going to next question. দেখো the lattice energy, কি বলছে, lattice energy of lithium fluoride from Bond-Land equation is given by 1000 kilojoule mole inverse. তার মানে আমায় কি বলেছে, lattice energy U0 of lithium fluoride বলছে this is minus 1000 kilojoule mole inverse. Assuming that lithium fluoride and magnesium oxide to have the same values of Madelung constant, interionic distance and bond exponent, then the lattice enthalpy of magnesium oxide will be, I mean আমরা তো জানি U0 equals minus a z plus z minus e square by 4 pi epsilon 0 r0, মানে r plus plus r minus 1 minus 1 by n. এখন কি কি জিনিসগুলো সেম বলছে, দেখো these factors are same, এইটা সেম, ঠিক আছে, এইটা সেম, এই জিনিসটা সেম, Madelung constant যেহেতু সেম, ই তো কনস্ট্যান্ট আছে, বাকিগুলো these are constants. So the lattice enthalpy will vary basically with z plus z minus, তাই তো। তাহলে লিথিয়াম ফ্লোরাইডের ক্ষেত্রে এটা বলছে যে 1000, if it is 1000 for, তার মানে এই জিনিসটা বলছে 1000 for lithium fluoride, নেগেটিভ চার্জটা তুমি নেগেটিভ দিয়ে নাও, এইটা 1000 for lithium fluoride, ঠিক আছে। তাহলে for magnesium oxide, you know that Z plus Z minus দুটোই কি হবে? ম্যাগনেসিয়াম অক্সাইডের ক্ষেত্রে Z plus equals to Z minus equals to Z minus equals to, তাহলে it will become what? 4 times that of lithium chloride. So it will become minus 4000. So the answer will be this one. This is the answer. The shape of IF8 minus. If you look at the shape of IF8, now this is a special molecule. It has, it's more like this. এইখানে আয়োডিন যদি থাকে F, so these are the 4 fluorine atoms. আবার এইখানটায় আয়োডিন আছে, 4টে ফ্লোরিন অ্যাটম আছে। So basically it's more like a, if you look from above, so it's more like a square prism, square antiprism, very sorry, square antiprism structure like this. দেখো square antiprism structure, তাহলে এটা স্ট্রাকচারটা হচ্ছে স্কোয়ার অ্যান্টিপ্রিজম উইথ আ নেগেটিভ চার্জ। সো দি আনসার ইজ স্কোয়ার অ্যান্টিপ্রিজম। এটা তোমাকে জানতে হবে, you need to know this structure. It is square antiprism. Now regarding this, which of the following pairs are isoelectronic? So if you look at NO, 5 plus 6, 11, CO, 5 plus, we are counting the outer electrons, 5 plus, sorry, this is 4 plus 6, 10, O2 plus 6 plus 6 minus 1, 11, NO minus আছে দেখো, যে স্পিসিস গুলো আছে, NO minus means 6, sorry, this is 5 plus 6 plus 1, 12. তাই তো? So the isoelectronic species আর O2 minus কত হচ্ছে? O2 minus হচ্ছে 6 plus 6 plus 1, 13. So the isoelectronic species are these two. NO and O2 plus. So the answer is B. Okay, so we'll continue with this discussion in the next part. So currently I'm stopping.